So I said that there's interest in these moons, landing on these moons.
And they haven't landed on those moons then yet?
None of these, but they've had flybys, I know, of Europa. There's some really cool pictures. And there's a moon on Saturn, or that orbits Saturn, called Titan, and they landed on that one. So kind of look at the Galilean moons. Io is one of the moons that Galileo saw orbit Jupiter. And it might be a homework question again, but Io actually is ooey gooey or volcanically active, and the reason has to do with, I think it's on the next slide, the fact that it gets squeezed and squeezed and puffed up and squeezed and puffed up. Okay. Let's see if this plays. The other ones have been playing. No, I guess that's not all that good. It's just showing you,
Okay.
yeah, hotspots. Okay, we got that one. I was gonna. Okay, so Io, and it's got this kind of weird looking. It's got a lot of sulfur, like what you're seeing are sulfur compounds there. Okay, so the reason it has, the reason that it has volcanoes is that it is. Can you see where, as it orbits Jupiter, Io is kind of elongated, and then it's squished together when it's kind of the top and bottom one, but elongated when it's kind of the east and west one. Okay, literally, it's going like this as it orbits the planet, and that's because they call it tidal heating. And remember that Earth's tides happen because of the moon. Earth's tides happen because of the moon. Okay, and so kind of like that. It's not tides being pulled, but it's basically Io being pulled because of gravity. Okay, so and what's not shown here, and I think it's shown on the next slide, is that kind of the flexing that we're seeing as different positions as in its orbit also has to do with what the other Galilean moons are doing. So Io is the Galilean moon that's doing this. Outside of Io, we have Europa, another moon, and outside of Europa, we have Ganymede, and of course there's a fourth one, Callisto. Okay, but as they kind of come close, Io kind of elongates. Okay, responds to the presence of those moons. And so it's kind of like if you have a stress ball or a silly putty even. If you had silly putty and you squished it and you just take silly putty and kept kind of deforming it, it would get hot. Okay, basically what you're doing is you are adding kinetic energy to it and it's heating up. So that's kind of what's going on with Io. So Europa is, can you almost see that? Looks like a place you would go ice skating. It does look like an ice rink. And that kind of light blue is ice. Icy, crusty stuff. Okay. So it's thought that Europa and several of the moons that orbit these gaseous planets actually have, can you see that last figure over there? Actually have liquid water under their crust. Okay, so over here at the far edge, you kind of see this is liquid. Not any liquid, but it's liquid H2O. Okay, and so this could be a place where you could go fishing.
If there were any fish.
Drop a line down there. You know, but aren't you curious at what's swimming around in that liquid water? I just think that is so cool. So that is Europa. And this is even a better look at it. Doesn't that just look like there could be little critters swimming around in that? Looks like a fish tank.
It'd be interesting to find out.
What's that?
It'd be interesting to find out.
It would. And there's science fiction movies out there that are written about visiting these moons, and bad things happen.
Bad things always.
You think at some point they'd be like, this is not good. Okay, so Io, Europa. What's that? Ganymede. Tida. So this is just another large moon, got a kind of a pretty terrain. You see the pock marks or the impact craters. And then Callisto. And the end there, it's got a magnetic field. You're like, really? Now, how does that work? Okay. So switching planets. Okay, those were large moons around Jupiter that Galileo saw. This is another large moon, but it's around Saturn. Okay, so Titan is around Saturn. My slide should say that, goodness. Orbits Saturn. And yes, we have landed a spacecraft here. And I tell you, I have a slide that says what it is. I think it's Huygens. And Saturn has, or sorry, Titan that orbits Saturn. So that close-up that says 5 centimeters, actually that is an image from Huygens. So Titan has a system of precipitation, but it's not water precipitating. It is actually methane, CH4, liquid methane. Strange. So this is looking again at Titan, kind of the oceans of liquid methane on Titan. I can't remember. Titan's been in the news recently. I'll see if I can find my articles.
That's football.
What's that?
Football.
It looks like a football?
No, football. The Titans have been in the paper.
Oh. Those Titans. So those were large moons. Some medium moons of Saturn. And if you go out to the observatory, or even if you don't go out to the observatory, if you look through a telescope, you can sometimes see these are rings, these medium rings at different places in orbit about Saturn. And there's an app for that. There is an app for that. If you have a telescope and you're able to see these moons orbit Saturn, there's an app out there that can show you where they're supposed to be. And they look kind of like stars, but they are the moons. There's also an app for Jupiter's moons, but I think I paid $5 for the app. So Enceladus is orbiting Saturn. Isn't that funny? I don't say which planet. I guess maybe it's just assumed. But this orbits Saturn. And actually Enceladus, it's quite exciting, has these little geysers of water coming out of little fissures in them. So I think that was kind of surprising. Let's see if this plays. I don't think it will. Oh well. Okay. Okay. On to the blue planets, Uranus and Neptune. So here is a moon called Miranda that orbits Uranus. And it looks a little bit like Frankenstein, sort of, where it looks like maybe a couple of chunks kind of came together once they started to solidify, and it's kind of stuck together ever since. Okay, this is a moon that orbits Neptune, the farthest planet. So this is Triton that orbits Neptune. And sometimes they'll call it's got kind of a weird sort of texture. They call it cantaloupe terrain. Triton, I don't know if I have it in my notes. Let's see if I do. Nope. So the thing about Triton is that it orbits backwards. Triton orbits backwards. You know, we talk about the conservation of angular momentum, the conservation of spin, and so this is an exception. The cool thing about something that orbits backwards, like a planet, or sorry, like a, well, a planet too, but something that orbits backwards like a moon that's orbiting a planet, is that it makes it so that it's going spiraling ever closer, and so actually Triton is probably going to get close enough to Neptune where it's going to at some point probably not crash into its planet. It's just going to probably kind of break up and form like another little ringlet of material. So the moon is going farther from us, things that, and this is actually spiraling towards. Okay. So to kind of look at a couple of objects, kind of side by side, kind of a couple of rocky objects, of course, maybe you recognize Mars there on the left, kind of the Valles Marineris, kind of in its equator, that trench in its equator. And then this other one is Ganymede, I think that one of the Galilean moons that orbits Jupiter. So they look like they're both rocky, which they are, but honestly, the planets like Earth and Venus and at one time Mars was ooey gooey with regard to having liquid mantle. Now mantle is rock, so basically it's liquid rock, okay, that plates can slide on. But a little bit ago we saw that the Galilean moons had liquid water, not liquid rock. Okay. So the tectonics are different. Okay, so it's sliding around on liquid water instead of sliding around on liquid rock. Okay, kind of wrapping things up, I think. So Saturn's rings, it looks like you could go up and, through a telescope. It looks like they're very substantial, but there's gaps in the little chunks that make up Saturn's rings. And they orbit near the Saturn's equator, and they're very thin, and they're very beautiful. So I think we looked at this before, where it's not one solid piece, but it's little pieces. Very reflective ices. And there are some gaps in the rings. Okay, can you see the cute little moon that's creating one of the gaps? So we said that all gaseous planets have rings, and I think we're convinced that they also all have at least one moon, one satellite, so they all have rings and moons. And here's a look at kind of the invisible rings around Jupiter, Uranus, and Neptune. So just in general, rings can actually kind of come and go. They can disappear, dissipate, and then be created. So let's just find them all done. Last slide.
What was that Jovian? What was that? Moon? Sorry.
You're fine. And the last slide. To kind of describe. I like to picture more than the words. I'm kind of a picture person. So we wouldn't always be privy to such a beautiful display of rings. Okay.